In this presentation, we're going to learn how to analyze a single replicate of a 2 to the 4th experimental design. So 2 to the 4 meaning that we're going to have two sort of options, and then in our case we have 4 different factors. And we're going to do this in minitab, and minitab has this like sort of wonderfully awesome embedded method for doing an experimental design such as this. And so when you actually go and are working on the homework assignments, I suggest that you really get to know how to do this in minitab because it'll help you out in the future. So the purpose of this type of analysis is essentially for us to determine what factors affect the production of computer code by programmer. So in this design, you'll see that we have 4 different factors. Our first factor is light, so whether or not their cubicle has light. The second factor is whether or not the computer programmer ate pizza, whether or not they have a big cubicle, and then whether or not they had Mountain Dew. And what we measure for each programmer is their actual performance output, which is measured in PPUs. So let's go in and actually analyze this. So what you need to do is go up to Stat, DOE, or Design of Experiments, hit Factorial, Analyze Factorial Design. This is basically saying, hey, you haven't really created your design yet, so I'm going to hit Yes, and I'm going to create my design. So I'm going to select my 4 factors, and they go here. Then you can go in and click this high-low button. You can see it, it's right here. So click that and this window pops up. And you can see that what it's done it's telling me that there are 2 numeric values for each factor, and the low value is -1 and the high value is 1. Then you're going to click OK. And once we've sort of put together what that specific experimental design looks like, then we're going to specify what the responses are, which are basically what is our measurement. Then we're going to go to the terms, and we're going to select 2 terms. And basically, if you're doing an experiment with a single replicate, it's helpful to use higher order terms to estimate noise values, particularly to estimate standard error effects and standard error of effects estimates. So we're going to hit OK. And then the next thing we want to do is we want to go to graphs, and we're going to select the normal graph. And you'll see that we're going to have an alpha value of 0.05, and then we're going to hit OK, and then OK. So here you can see our graph, and if we scroll up and look at our data, you're going to see first that it tells me the factor effects for each factor. So for there being light or not light, for pizza, cubicle size, and Mountain Dew, you can see the different effects. And then you can also see the different interaction effects. So A with B, A with C, A with D, B with C, blah, 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 and so on and so forth. It also tells us the coefficients. So these are the sort of they're the linear regression coefficients. And then it tells us the standard error of these coefficients. And then it also gives us a t-value, and that essentially allows us to test the statistic. So this is our t-statistic. And from that, we can calculate our probabilities. And so with a small p-value here, so such as with pizza and Mountain Dew, and the interaction of pizza and Mountain Dew, we can essentially say that these factors and then this interaction between the pizza and Mountain Dew factors are significant factors for us to consider. So then we can pull up this normal plot of the standard effects, and this is a normal plot of the residuals from our regression model, and therefore the residuals are pretty much, they fall on a straight line here, and that tells us that it's normally distributed. So if you go back to when we were, figuring out whether or not data was normally distributed, remember it had to fall on a straight line, and so this plot is showing that, yeah, it's pretty good. It's a pretty good normal distribution, and so that tells us that it fits the data well, and that we don't really need to go in and compute other coefficients to improve our model. So the next thing we want to do is see if there are any interaction effects. So we can go back to our thing, and we can hit factorial plots, and we can do, in this case you can see we can do a main effects plot, so that would be plots of the effects that are significant, and then we can also do an interaction plot. So we're going to actually do the interaction plot, and in our case, because when looking at the data we see that the interaction between pizza and Mountain Dew is pretty significant, we're going to select those, and our response is going to be there, and we're going to go okay, and okay, and you can see our interaction plot. So when we look at this plot, we see that these two factors interact, and in that they, intersect here. If they were parallel, then we wouldn't really be concerned. But because they interact, it tells us that when we are trying to help increase performance with our computer programmers, that we probably need to do these two together. So you can see that if we just look at Mountain Dew alone, that if they're given Mountain Dew, that their performance actually goes up. And then if we add just the pizza in a little bit, it actually drops the performance a little bit. So we can see that this interaction can have a negative impact on the productivity, but ultimately Mountain Dew is a really good thing, so we'll just give them Mountain Dew, and hopefully their productivity goes up. So I hope you have a better understanding on how to analyze a single replicate of a 2 to the 4th experiment design. Thanks.